Who knows what show this is from? No, never seen it. So it's yeah, quite a few. So it's a show in the UK called Little Britain. And if you haven't seen this sketch, you've probably experienced this thing in real life where you're speaking to a human in, let's say, a bank or an insurance agency or a travel agency, and you're about to get what you want, and then all of a sudden, the person that you're speaking to says, the computer says no. You can't have this thing that you thought you were going to have and that I thought you were going to have. And what is frustrating about that is that the face-to-face, warm, human-to-human contact that you had is now broken. The computer has put an end to that conversation. And she doesn't have any power to change it. And in fact, maybe she doesn't even understand why you have been denied a credit card or a seat on this plane or whatever. So I'm going to make the case during this talk that what is a mild irritant with situations like this is actually going to get more and more serious as the things that AIs do for us become more and more impactful on our lives. So I'm going to quickly review what we've been doing at Wealth Wizards with this. So we work in financial services. What have we done? How have we been able to use explainable AI? And that's kind of a case study that we can generalize to all professions. Then we're going to dig into an algorithm, which is one of the leading algorithms for providing explainability to your models, called LIME. And then we'll have a look at the ethical considerations around making your models explainable. So just quickly then, what we do is help people to figure out what to do with their finances over the long term. If they're trying to figure out, how do I save up for my daughter's wedding, or how do I pay off my student loan, or how do I prepare for my pension? In Britain, actually, we're terrible at all of those things. But you can imagine that any advice that we give to people is majorly impactful on their life. And so if we were to say to them, you should take your money out of this thing and put it in this thing, or you shouldn't pay off your student loan for a while, you should do this other thing instead, then of course they're well within their rights to say, well, why'd you say that? And why'd you say that specifically to me? Do you say the same thing to everybody, or has this thing been tailored to my personal circumstances? And the advice that we're giving is delivered either direct to consumer through through some kind of app, or through a paraprofessional of some kind. So a paraprofessional is somebody who's not fully qualified in an area, so is not a fully qualified financial advisor, for example, but who works for financial advisors. And with their qualifications that they have and the AI supporting them, they're able to give advice to the same level as any kind of fully qualified advisor. So that's a thing that we can generalize to lots of different professions. This study that is on the screen there has been done by somebody who's a very long-standing lawyer, and his son, who's a fellow of economics at Oxford University. And they've said that actually what is happening in financial services is happening across all professions, that slowly this monopoly that professionals have on a particular body of information is eroding as people are able to get information from not just information, but practical expertise from the internet and from AI systems. And so there are medical systems now that can tell better than human experts whether this thing on your skin is a melanoma or not. We've got systems that can give you legal advice. We've got systems that can tell you how to architect your house. And of course, any advice that you take in any of those areas is going to have a huge impact on your life. And so you're going to want to know, okay, what specifically? Can you explain what are the steps that you took to arrive at that advice? And why should I trust you? Trust is a theme that we're going to come back to a bit later. So typically when we're choosing a model, we have to make a trade-off between, do we want this model to be explainable, or do we want it to be really accurate and powerful? And over at one end of the spectrum, you've got decision trees where it's very easy to see, okay, I can see that somebody asked a customer that question, they answered this thing, they went down that branch, and then they went down this other branch, and so on. And that's explainable. The same goes for linear regression. But once you get all the way over to the other end of the spectrum, to neural networks, then if somebody were to say, okay, so you're telling me that I should get a divorce, or you're telling me that I now have to go to prison, tell me why you had to do that, then a neural network's explanation is, well, there's your massive tensor full of theta values, work that out for yourself. But that doesn't need to be the case. So the field of explainable AI allows you to choose whichever model you want to use, and then tack on an explainer as like a post-processing step. So in this example, we've got a model which is saying that we think this person has flu. So the doctor would normally prescribe a particular piece of action, but as a proper professional, he wants to know, well, how do we know? You tell me, and I'll make my own decision. So in order for him to be uplifted, his skill to be uplifted by the AI, he wants to know, can you explain your reasoning? And so an explainer module would pull out the 2 or 3 factors, or the 4 or 5 factors which are most relevant, which were weighted most highly in this. So there's a few different ways of achieving this goal, and one of the most popular ones, which we're going to talk about today, is LIME, which stands for Local Interpretable Model Agnostic Explainer. And if you Google that phrase there, why should I trust you, that will lead you to the paper itself. So the way LIME works, again, it's like a post-processing step, is it tries to work out what factors are being taken into account, what features are being weighted most heavily in a particular local area of your model. So if that boundary there, that blue and pink boundary, represents the decision boundary between 2 different classes, the crosses and the circles, then the explainer is not able to, is not aware of that. That's invisible to the explainer, but somehow it's got to try and figure out, why did you say that this guy had flu? Or why did you say that this guy shouldn't be granted parole? So obviously in this model, you'll forgive me if I'm only talking in 2 dimensions with 2 classes, but we can see how this extrapolates. In this case, the largest cross on the screen there is the instance that we want explained. So we've gone away and we've trained a model. We've passed one instance through the model, and that's given us a classification K. And we then want to see, right, what are the main factors that we're taking into account in there? In a neural network, there might be dozens or tens or thousands of classes. What were the main ones that led to this decision? And the way that LIME works is it takes the features of the instance that you just passed in and modulates them. So it jiggles them up and down, and it tries to measure. So it will jiggle, let's say, the age, or the amount of sneezing that somebody's doing, or how violent somebody's been in prison. It will take that metric and jiggle it up and down and see, when it then passes it through the original model, does that change what the class is? And you can see that things that are close to the big red X lie on one side of the boundary or the other side of the boundary, and there'll be certain features that you can tweak that will push the thing over into the other classification. And so LIME starts to get a feel for, I see, so small modulations on this one feature make a big difference to the classification, whereas massive modulations to this other feature, so you can see the tiny little X's way over there on the right, way over there on the right, they're not making much of a difference at all. So there are X's even though they're way over there. So it'll take all of these features, modulate them to produce classifications, and then at that local point, and this is the key bit, we'll train a more explainable model. So let's say a linear classifier or a logistic regression to see, can we see any pattern here? And that's how it learns which features are the most interesting. And later on in the paper, they talk about how you can then rank. So that will give you some explanation. But there are then ways of trying out lots of different types of models against each other, and then ranking them against how complex they are. So that if you've got 10 features, that's more complex than a model with 4 features. So it can help you try out multiple different ways of explaining the same thing using decision trees, linear regression, logistic regression, and so on. So that's how it works with logical data, but this can also be used it can be used with any model. That's what the M in LIME stands for, model agnostic. So in convolutional image data, for example, the way that we apply the same algorithm is to take pixels, whether the features in this case are pixels, take those and turn those on and off, and jiggle windows of pixels at a time to see if we can find, are there features in here that we think help us to classify this Labrador playing the guitar as a Labrador playing the guitar. So they're what the paper calls super pixels. And we can see from the first image that's grayed out, they've turned off a whole bunch of the pixels and figured out that this thing that looks like a fretboard looks pretty much like an electric guitar, whereas the things that the body of the guitar look more like an acoustic guitar, and this cute little nose and the ears and the kind of smiley face, well, they look like a Labrador. So that kind of thing is super understandable to anybody who's not an expert in machine learning. You don't need to be an expert in machine learning to understand that. And in fact, there are techniques explored later on, which we don't have time to talk about now, where you can get non-expert humans to improve the accuracy of the model itself. Over time, you can say this thing's not helpful, this thing is helpful, and help the model itself to improve. So let's just have a look at some code for how that works. The code for this is pretty simple to get started with, at least. We've got this Alaskan husky, I think it is, sitting there with a cat, and we want to pass this into Google's Inception classifier to see what it makes of that. And quite quickly it comes back with, yeah, I think that's an Alaskan husky. But the important thing that we want to focus on is how does it know? So there's a couple of lines at the end there, and I wish now I'd put line numbers on my code. The 2 lines at the end are where we set up the line classifier. And remember that I said what we're doing is we're giving it an image and passing it through the model again and seeing what it comes out with. So the image that we give to the line classifier is then going to jiggle around all of those features, in this case, turn groups of pixels on and off to see what it comes out with. And we can then paint the area of the pixels that are most important onto the image so that we get a feel for what that looks like. So those, just in those 4 lines there of Jupyter code, we've managed to identify that this is an Alsatian. No, what was it? Some husky of some kind. So these kinds of models help to build trust in the model. And trust is important to a lot of different stakeholders, actually, in this argument. In the kinds of fields that we've spoken about, so in crime, so in the criminal justice system, or in medicine, or in financial advice, obviously the end consumer is very, very interested in, well, you say that I should make these major changes in my life, but how can I trust that? They need more than just a yes or no answer or a set of things that they need to follow. And so this, okay, this is quite rudimentary at the moment, but you can see where this is going. These ways of speaking to our customers will help them to build confidence in our model. In areas where you've got para-professionals, so you might have doctors powered up by using AIs, or you might have architects who they just get an AI to design a set of houses. Or in the case that you've got a judge taking advice from an AI. They want to be sure that not just the individual predictions are correct, they want to be sure that the whole model is correct. And so Lime gives you a way of choosing a whole bunch of cases, run them through the system to see how does this model perform as a whole? Is that something I can trust? If not, is it something I can improve on so that I can trust it? Or shall I choose another model altogether? Then you've got regulators. So in lots of industries like aviation, for example, you've got aviators who are interested in why things are working the way they are. And so think of a self-driving car. If that has had an accident, that's run into somebody, what was the thought-making process that the AI ran through to make the decision to run into that pedestrian? And you can imagine that at the moment we've got the data in a format that the manufacturers can understand. But wouldn't it be better if we had it in a format that other people who are interested in the safety of humans could understand, people who are incentivized by different motives in a format that they could understand? And then you've got ethics bodies. Let me just skip through to this. So I thought this was a really interesting quote. IBM think they've got a classifier that can tell the difference between a refugee and a terrorist. And once we start getting into this kind of world, that's quite a scary world that we want that we live in. That we want people to be able to have quite sharp scrutiny on those types of on that kind of research. And I personally would like that kind of scrutiny to be more well-informed than the kind of scrutiny that Mark Zuckerberg was undergoing when he was speaking to the American Congress. That questioning was quite woolly, and when we're talking about autonomous weapons, and when we're talking about classification of peoples and races and stuff, I want the questioning to be very pointed. And so having an explainable AI that is understandable by ethics bodies, I think is really, really crucial. So people are in two minds. Non-experts are in two minds about where all of this is going. You know, did you see the thing in the news recently that an Alexa was recording a conversation? I think they were talking about their nanny, and it sent the conversation to their nanny, and everybody was embarrassed. And then there were things in the papers all over the place saying, are we being too complacent about AI? Is AI going to take over, ruin our way of life? You've got massive pessimists on one side and massive optimists on the other side. Where is this going? Are we leading to a utopia or a dystopia? And I think the more clarity that we can shed on how our models work and what AI really is under the hood, the more we're going to convince people that this is really a utopia. We stand a chance of making the world much better through AI if we all understand it. Thanks.